grades. Whoop, whoop. All right, let's do this. This is 1.1 numerical expressions. So your learning target today is I will write and evaluate. Ooh. I will write and evaluate. Fancy word for solve. Numerical expressions. Take a minute, go ahead and do the warm-up. Pause this. By the way, as you go through these videos, this is the first one of the year, but as you go through these videos, when we get to things, just pause them, try them yourself. It's the best way to do it, and then come back and you can see me working through them. Ready, set, go. All right, I'm assuming it was paused. We all succeeded. All right, don't forget, important little piece of information here is plus plus equals plus, minus minus also equals plus, plus minus equals minus, and minus plus equals minus. Boom, have that written down, all the good stuff. All right, these are touching, so a plus minus makes a minus. That's how we use it. So I have negative 1 minus 17, which is negative 18. Right, here we go. Those are going to become a minus. Then I'm going to work it left to right. 21 minus 13 is 8. So I'm going to have 8 minus 4 equals 4. Let's square my answers. Two negatives make a positive, make another positive. I have negative 8 plus 7 is negative 1, plus 2 equals 1. Right here, these make a positive. Negative 5 plus 4 is negative 1, plus 3 equals 2. All right, we've got a little vocab right here, and I've already written it several times today, so I'm going to just display it for you guys. Ooh, right here. What do we got here? A numerical expression is a mathematical phrase involving only numbers and mathematical operations. An exponent, x to the n, where n is the number of times x is multiplied by itself. The base, when we have x to the n, x is the base. To evaluate means solve or find the value of the expression. All right, go ahead again and pause this because I'm going to move on pretty quick for video's sake. There we go, going. All right, today, guys, we are talking about PEMDAS. That is parentheses, exponents, multiplication, division, addition, and subtraction. All right, now, you'll notice I have multiplication and division at the same level. Same thing with addition and subtraction. When we have a problem, so if I were to write, I'm just going to use my space up here, if I would have something like 3 divided by 5 times 2, their multiplication and division are at the same level. So if I have a choice between them, I'm going to do it like I read a book, left to right, okay? So I would do division first. In the same way, if I had 3 times 5 divided by 2, those are at the same level, so I would work it left to right and do the multiplication first. It just depends on what comes first when they're on the same level. Same with addition and subtraction. So this is super important. In fact, this is one of the most foundational things of algebra, knowing how to solve when and what order. All right, and let's look at this. We have multiplication. It's above addition, above subtraction, then their multiplication. So I can do my 2 multiplications right here. Right here I have 3 times 20 is 60. I'm going to have plus 3. And don't freak out at 8 times a half. It's just saying what's half of 8? It's 4, so we have minus 4. And again, 60 plus 3 is 63. Minus 4 equals 59. Now, number 2, addition sign. All right, now I'm going to do parentheses first. So this is going to be 3 times 7 divided by, and what's 5 plus 2? It's 7. So now I'm going to have 21 divided by 7, which is just 3. Kind of went backwards, right? Times 7 divided by 7. It undoes itself. Boom. Take that in. Different ways to say 2 times 3. Well, there's always 2 times 3. We have the 2x3. Or I could say, hey, in parentheses, 2 times 3. Or I could say 2 times 3 in parentheses. If I want to get really crazy, all the cool kids, 2 and 3 in parentheses, because parentheses next to parentheses is multiply. Awesome. Again, as I'm going fast, because this is a video, right? So just kind of pause is needed. Translate the following numerical expressions and evaluate them. So we are going to evaluate these. So this one is what? Well, plus just means plus, divide means divided, and minus is minus. So I'm going to have 5 plus 21 divided by 3 minus 1, which PEMDAS says do division first. So I'm going to have 5 plus 7, because 21 divided by 3 is 7, minus 1, which is 12 minus 1, or 11. Awesome. Take a minute, try these ones. One thing I want to say before you do, though, whenever you see sum of, so in fact, I'll do this one, then let you try the last one. Sum of, when you see sum is plus, but when I say of, I'm saying put the next 2 numbers in parentheses, so 2 and 7. So that means I'm going to have 2 plus 7 in parentheses, and then divided by 4. It's a way of forcing a lower level operation first, right? So normally I do division first, but because this is in parentheses, I'm going to do it first, get 9 divided by 4, which is 2.25. Try this next one, see if you can write it out. Ready, set, go. Okay? Again, I'm assuming you paused me. The difference of, so it says difference of, so I know it's going to be parentheses, right? 10 and 5, so 10 minus 5. Multiplied by 4, we can just put 4 because the number next to parentheses is multiply. Divided by 10. So let's do this. That's going to be 5 times 4 divided by 10. Or 20 divided by 10, which equals 2. Look at that. Sweet. Okay, let's look at this right here. Don't forget, in an exponent, this is the base. This is the exponent. This is exponential form, but the exponent is the power we're raising it to. And what does an exponent actually mean, guys? Well, 3 to the 3rd power doesn't mean 3 times 3. It means 3 times 3 times 3. This exponent tells me how many times to multiply the base times itself, which ends up being 27. In the same way, 5 to the 3rd is not 5 times 3. It is 5 times 5 times 5, which equals 125. Once you guys take a minute and try to figure out these next few, go ahead and pause it, see how far you can get. If you get stuck, it's okay. I'm going to work through all of them in just a minute. Go ahead, pause this. All right. I'm assuming you paused, tried everything. You can even pause in between problems if something I do helps ring some memory here. So we got to do parentheses first. 7 squared equals 49, because that's just 7 times 7. Right here, no parentheses, but there are exponents. That's 2 to the 2nd power, which is 4, so I'll have 16 minus 8 divided by 4 plus 14. 8 divided by 4 is 2, so 16 minus 2 plus 14. That's going to be 14 plus 14, which equals 28. Boosh. Jaden is playing darts. He scores a triple 14, a double 17, and a 10. Write an algebraic expression to calculate his total. Okay, so triple 14 is 14 times 3, right? And we're adding these all together to get the total score. So plus a double is 2 times. So we're going to have 17 times 2 plus 10. And that's what? 42 plus 34 plus 10. This comes up to be 76, so 86. His total score is 86. Jaden's score is 86. Word problems get word answers, right? Okay. Right here. Now, I'm going to show you something. This fraction bar, if you don't know, it means divided by. So because of that, I can actually rewrite this to be 4 times 3 squared divided by, and since that's both on the bottom of the fraction bar, it's like it's in parentheses, 9 plus 3. So let's do our parentheses first. We're going to end up with 12 squared divided by, and in these parentheses, 9 plus 3 is 12. 12 squared is just 12 times 12, or 144, divided by 12 brings us right back to 12. And our last one, parentheses first, look inside the parentheses, more parentheses, do those first. 2 plus 3 is 5. So we're left with 6 times 32 minus 5 squared plus 14. 5 squared is 25. We do parentheses first, exponents. 6 times 32 minus 25 plus 14. Excuse me, parentheses first again. 32 minus 25 is 7, so 6 times 7 plus 14, which is just 42 plus 14, or 56. There we go. Now I went through these kind of fast, but again, take your time, take a look at them. Pause it as needed, go back. Let's talk about the four-step plan, The problem, the gas gauge in Rufus's car indicates that the 17-gallon tank is half full. The car usually gets about 22 miles per gallon. If Rufus just passed the sign, should he plan to stop before reaching Columbus? And what does the sign say? It's hard to read, but it says 68 miles to Columbus, so 68 miles. That's how far he needs to drive. Take a minute, pause this, underline everything you think is important. Where does that go? Okay, so we're going to talk about the 4 steps, but first let's identify what's important. The gas gauge in Rufus' car indicates 17-gallon tank is half full, so now we can find out how much gas he has. The car usually gets about 22 miles per gallon. If Rufus just passed the sign, should he plan to stop for gas? So step 1 is identify, write this down because you didn't know this for the next couple of years, identify and understand the task. Let's underline that. What is the task? Well, ultimately, does Rufus have enough gas to make it to Columbus Columbus, or should he stop for gas? Step 2, we're going to plan our approach. Now, it's interesting, a lot of these can have multiple approaches, just like this one. One approach could be find out how much gas is needed to go 68 miles, or how many gallons he would need, and then compare that to the gallons he has. To make it. Or we could calculate how far he can drive on half a tank to see if it's enough. That's kind of the two options I see. So step 3 then is solve the problem. Now for this one, guys, you can use any method you want. I'm going to go ahead and let's find out how many gallons he needs to make to Columbus. Well, if it's 68 miles to Columbus, and I know he gets 22 miles per gallon, let's see. I'm going to guess if he used 3 gallons of gas, 3 times 22 equals 66. That's not quite enough. So he would really need to have Actually, you know what? Let's do it the easy way. Let's take 68 and divide it by 22 and see what we get. Oh, you don't even see me doing that. On 68 divided by 22. So it needs about 3.1 gallons of gas. Approximately 3.1 gallons. And let's see how much of gas he actually has. It says he has half a tank. So that's going to be 17 divided by 2, which equals 8.5 gallons of gas. If he only needs 3.1 and he has 8.5, he has plenty of gas to go. So right now we can say Rufus can make it to Columbus without stopping. It's my shorthand for with. Without stopping. That is our answer. We just proved it. Step 4, though, you may be thinking, we've already done our steps, so what do we need to do next? Well, we got step 4, and guess what step 4 is? Check your solution. Guys, I give lots of partial credit, and much of the partial credit I give if you get an answer wrong, but you show your work, is do you check your solution? Okay, so let's try the other way. Check our solution. If he has 8.5 gallons of gas, what's 8.5 times 22? Because he gets 22 miles to the gallon. 187. 187. Well, he only needs to go 68, so 187 minus 68 miles, right, is going to be 911. He will be able to go 119 miles past Columbus, so he could literally go to Columbus and back. He can go to Columbus and back on this. On his gas. So we just proved he has more than enough. He is good to go. All right. This is today. You got your homework. Go ahead and get that completed. And without further ado, peace out.